All right, so like I was just mentioning, we're going to talk about basically Mod5's project. And so as you, has anyone, just kind of give me a thumbs up, has anyone looked at the Mod5 project on the curriculum already? Okay, I see a couple thumbs up, some nods and stuff like that, cool. So there is a couple things I do want to mention about that on the curriculum that as instructors we have found end up being more helpful, unlike things that to modify. And so I'm just gonna kind of walk through it a little bit, okay? So I'm going to share my screen. And those people who haven't seen it yet, definitely go through the material. I'm just going to very briefly go through it on here. Where is my, sorry, everyone. Cool. All right, so I can see your guys' warm faces. Except for people's cameras who are off. All right, so Mod5 project, you guys will be doing a machine learning project, essentially. So one thing to note about this, the main focus is not the cleaning data, the like aggregating data, data acquisition. So it's not like there's even less data exploration. You'll still probably do some data exploration because you should really think about exploration as every step, making sure you know what your data are and everything. But the main focus is going to be the actual machine learning predictive modeling parts. So I'm just kind of looking at what the curriculum kind of shows here is that the big thing about it is that you're going to be selecting your own data set. So you get to decide what is your data set, like what you're going to do with your data, or what kind of data you have. And so one thing, this is where I'm a little, since, I'm grading your guys' Mod5 project. The curriculum does mention about using classification. I would be perfectly fine if you guys do have a use case for doing unsupervised learning, unsupervised learning instead of supervised learning, which would be classification. That's perfectly fine. I think most people will gear towards classification just because it's a little bit, as your first project, it makes a lot more sense. There's a lot more options for you to play around with. But if you're curious about doing like, something like an unsupervised learning problem, that's perfectly fine too. In fact, you can take a lot of classification problems and turn them into unsupervised learning and explore it in that way. Okay. So there's a few things in here, and I'm going to read off a few of them that are important, and then I'm going to say a few things that are different, because this in particular is going to be a little bit different from what's actually in the curriculum. So another thing, make sure like your data is sufficiently complex. And so what is important about this is that if it's too simple, like you can do machine learning and stuff like that, but it's not going to be very satisfying. And also I think of this project as being something that you can kind of test out and kind of play around with, like machine learning. Also, you can think of this project, this is one of the last projects. This is literally the last project before the capstone. You can think of this as a big one, either that leads into a capstone. So a lot of people will pick an interesting problem, they play around with it, and they're like, I really like this. Like, I want to go ahead and try to do this for capstone. Or you can also think of this project as being like something you can take into an interview and say, hey, like someone's asked you, tell me about a machine learning project you've done. You can bring this up. If it's too simple, it's not going to be very interesting to talk about. And honestly, there just might not be a lot you can kind of get from it. On the back, it's like, oh, it worked or didn't work or whatnot. And most likely, if it's too simple, it's probably going to work and all that stuff. Things to avoid. So you guys probably recognize the iris data set. I've been using this almost like exclusively for this past like module, but things like Titanic and MNIST, really common data sets. Try to avoid those just because, again, part of the reasons you're putting this as a project for like a portfolio, you don't want to, like, I'll tell you right now, don't put, like in the future, don't put like on your resume, did Titanic, data set or iris data set, or I mean, MNIST might be all right, but definitely not Titanic. Like there's been a few of them I've seen, like resumes, people in Titanic, like, oh, did the machine learning model in Titanic? And it's like, it's so overdone that like, it's not impressive at all. It's kind of like saying I've typed Python, like in like a code. It's like, oh, that's not really that exciting to talk about. So just kind of a warning on that case. But I'm pretty sure if you find something that's interesting to you or has some kind of professional experience kind of tied to it, and we'll talk about some of that stuff, you'll probably find a decently complex one. I have had in the past someone give me a data set, it's like, oh, I'm really interested in this one. And I'm like, it seems a little simple. And they're like, yeah, but I really want to try it out. And I'm just like, okay, well, go for it. And they said afterwards, they're just like, yeah, they could feel like there wasn't much to it. Like they felt like there wasn't much meat to it. So I'm trying to help you guys avoid those kind of things. Okay. Note that simple does not mean like dirty data. You can have clean data. Like that's a good thing. And we'll talk about where you can find that clean data. So this is the other end of the spectrum, right? Is that you don't want it too complex. If it's too complex, it's going to take you a lot of time. And the big ones we're going to talk about are things that are like natural language processing, so NLP, or computer vision. And people are like, now what's natural language processing? Because we haven't talked about that really, right? Just know natural language processing, anything like translating words or word frequency, basically anything with like language. Would be something you can do with machine learning, but we really haven't given the tools for that yet. And it's going to take a lot more time to do that for this project. If you want to do something for your capstone for NLP, that's perfectly fine. But for this project, I would definitely stay away from it just because we haven't talked about all the different ways you can kind of treat this stuff. Something similar with computer vision, basically anything with images. So like if you're doing images, there's a whole extra part to that. One is just storing the images. It's a lot larger data set. Also, we haven't talked about how to process image in the sense of like, how do you feed it into a machine learning algorithm? And the third one is that a lot of the algorithms we have, you can technically do some computer vision with it, but it's not going to be the best usually. Usually you need a little more complexity to the models that we have. So this will be for, especially in mod 6, where we'll talk about NLP and computer vision with like neural networks and convolutional neural nets and stuff like that. So if you're really curious about this stuff, like I really want to do this, hold it off. Definitely think about it for capstone. Okay, cool. Any questions so far that kind of going through these bullet points, these projects? Pretty good, cool. So right here, the curriculum kind of says like serious bonus points using like a third-party API. I would say avoid this unless you like, I shouldn't say avoid APIs. APIs can actually make really clean data, but I would avoid doing web scraping or adding more complexity in data acquisition for this project. Because remember, this main project is going to be about doing the machine learning part. And I think of this project as being something like, try multiple models out and try things out and get a feel for this data set and see like what works well. And that way, when you go into another project, when you have to collect this data, you have a kind of a feel of like what kind of stuff works well. Okay, cool. All right, so this is where I'm going to highlight this guy right here and say, all right, this is where I'm going to differ very differently from here, and it's really for your benefit. So one obvious thing I'm going to ring true is don't use one that's already in the lab. Like obviously you just want to have something that's interesting. Plus the ones in the lab are just not large enough really to do interesting machine learning. And this is where I'm going to really differ from the curriculum. It says a minimum of 1,000 rows. I and a lot of the instructors agree is that this is too small for a machine learning data set. Can you do machine learning on 1,000 rows? Yeah, but it's kind of in the same vein of like too simple. So what I'm going to say is like really shoot for like minimum 50,000 rows. So like basically 50,000 data points. And there's a lot of data sets that are like that. Does it have to be like if it's like 40,000, is that like too small? No, that's fine to like be about that. But I think if you shoot for 50,000, you'll be pretty set. I will say like having more data isn't necessarily a bad thing in this situation. But I would say between 50 and 100,000 would be your Goldilocks zone. If you find a data set that's like, more like larger than that, like 500,000 or something like that, you can just say, oh, I'm going to use the first 100,000 or first 50,000. You don't have to worry about that. Versus if you only have a small amount of data, sometimes it's just harder to get results from that information, or it's too easy in the sense that like you'll get really obvious results and you're like, well, then kind of like what kind of like what was the point of doing the project? If hopefully that makes sense. Okay. Same thing with this the minimum number of 10 predictor columns before one hot encoding. This kind of is similar, but I'm going to have a little extra part in here that we'll go over in a little slideshow that another instructor put together that I kind of agree with. But basically, one thing you want to do is try to avoid data sets that have a lot of categorical variables. Not that you can't do machine learning with all or most categorical. You just will find that they will tend to perform either really well or they don't perform well enough. And it can be a little frustrating being like, well, there's not much tweaking you can do essentially, at least from the stuff that we've learned so far. So I would say aim for, I'll put this in the slideshow, but about 50% numerical features before one hot encoding. And that there really should be about 8 of them numerical continuous features. So be like at most like, anyway, so like try to avoid a huge amount of categorical features. Does that make sense to people? Okay, and I'll reiterate this stuff. And then just know this last part. Oh, question. Yeah, go ahead.
Are you saying no more than 10?
No, so
Or it needs to be
like
at least, sorry.
at least 10. I think this will make more clear. I'll be more clear in the slideshow what I have, and I'll give you
Okay.
guys
All
access to
right.
that slideshow. But the main thing is just having making sure it's not a majority but categorical. Okay.
Okay, it's more like the ratio. Okay. All right.
Yeah. I know. I kind of said that in a confusing way because I'm trying to address this, but also like say the right thing. But yeah. Okay. And then the rest of this stuff, like your normal stuff, is we'll talk about where you can get data and stuff like this. One thing you can do, there's a couple ways you can approach it. You can think of a problem first, or you can think of like what kind of data set would be interesting, and then figure out what kind of thing would be interesting to model around that. Either of these approaches are fine. And we'll talk about where you can get this. I also have another resource that I would like to point out. And then your deliverables, Jupyter Notebook, your README, your blog post, and then your PowerPoint. So one thing about the PowerPoint, they'll be slightly more technical, likely, about talking about like what you're modeling. However, you should still gear it towards a non-technical person. It should be understandable for someone who might not be as familiar with data science like we've done in the past. Okay, cool. Any questions about any of these deliverable parts? I think this is pretty standard now. You guys got a pretty good deal. Cool. Okay, so I have a little, what's it called? A little slideshow here that actually another instructor had put together. And so it's not my originally, but I agree pretty much with the whole thing. I'll talk about a little bit what this is. And I will also give you guys a link to this slideshow too, so that way you guys can go through it. So don't feel like you have to write down everything furiously and stuff like that, just so you know, okay? So this is about, we used to have where we chose multiple projects. So there's a couple projects where you would choose your own data set. Mostly this will apply a lot to Capstone too, but this in particular will be about Mod 5's project, okay? So when you're actually picking, so this is a few things we're gonna talk about, and I'll be kind of quick with this. But so when you're thinking about like what data set to pick, really think about like, there's a kind of couple ways you can think about it. One is like your professional experience, meaning like either what you have experience in or something that you want to go in. So if you want to go in a certain field, let's say like you're thinking in like near future, you're looking to apply to a certain field and you kind of know what things they're interested in. For example, let's say you want to go into finance and you wanted to do something related to finance. That would be a good one to do for your little project here, especially going into Capstone. You can think of this like almost like what a lot of people will do with this project is they'll take this project, see how well this performs, or like see how, you know, kind of test the waters out, and then they'll kind of vamp it up even more for their capstone. So if this is something that you're interested in doing for certain professional experience, either you have professional experience in these areas or you want to get into these areas, this might be a kind of data set you want to think about. But another part you can think of just whatever you're like interested in. Like, you know, there's a lot of people who will do sports in this case, just because they're interested in sports and they like to see how they can apply this with machine learning. But there's a whole bunch of other things you can do. And I personally will say is that if you're looking between these two and you're not really sure about professional experience, like what exactly to do, go lean towards the personal passion. And the reason why is because in an interview, if someone were to ask you, tell me about a project, or even not an interview, just talking to someone who might be potential connection for like, you know, applying for a job, they ask you about a project, it's a lot easier to talk about a project that you're passionate about or like we're at least interested in versus something that might be interesting to other people, but maybe it didn't like ring, it doesn't really ring true and like why it sounds special to you. So I would even say like if you're going between these two is that I tend to lean towards saying a personal passion project because it in a lot of ways, it doesn't really matter specifically what kind of project you're doing, more like saying, do you have the skills? Because a lot of these skills, no matter what project you're doing, can be applied to many different areas. And that's my personal kind of like opinion, kind of like suggestion. But of course, if you have something that you're interested in and you want to go in a specific field, that might be some interesting data sets to look into. Okay. Any questions on that between these different two data sets or twists? Cool. All right, so here's some criteria. So this is going to be a little bit different from what the curriculum has, and this is what I'm going to be looking for. So remember, first of all, is that whatever data set you find, you should run it by me and then have it approved. I'll put in a soft date of like when that should be, but since next week will be project week. I would say at the latest, get it approved by like mid next week. That way you can start getting into it. I don't want you to wait like a whole week trying to pick a data set. And then next Friday, choose it. It's like, okay, cool. Now I can start doing the project. And now you have like essentially only a week left of doing that project. So, and make sure you do that. But main thing, about 50,000 rows, which means 50,000 data, instances in the data set. And so this is kind of like that minimum, but I'd be like a soft minimum. If you have like 40,000, that's probably fine. But if you can get at least 50,000, that would be ideal. Okay. And then must have at least 8 continuous features before feature engineering. So before you do anything else, including one-hot encoding, you should have at least 8 of them to be continuous features. And the reason why is because it's easier to do machine learning modeling at this stage where you have a range of data. So you can imagine you have very small numbers versus very large numbers. You can kind of interpolate between the two. With categorical data, it's not as easy to do that. You can think of like, is it an elephant? Is it a monkey? Is it a dog or whatever? There's not really in between those parts. So you're kind of limited with whatever categories you're given. Also, what tends to happen too is that if you have many categorical, so like you should not have more than 50% of your features be categorical without one-hot encoding. The reason why you don't want to do this is that a lot of times by definition, some of these target values will just be defined by the category. And if you have so many categories, it's just by definition going to either work out, or the opposite happens where there's not enough information from just the categories themselves. And then you're kind of stuck in a place where it's not a fun thing to do because you really can't learn much more by doing machine learning model. In the real world, what you would probably do is do other things like collect more data or combine data sets or do some other feature engineering. Does that make sense to everyone? Okay, yeah, not to say that categorical variables or features are bad. It's just that for this project, I would say try to focus on getting more continuous features. Okay. Here's a little note about DIY data sets. This is where like it's perfectly fine to get data set like web scraping or other methods where you have to essentially collect this information. However, for this project, because it's mostly going to be focused about doing the machine learning aspect, I really suggest not doing like kind of web scraping or kind of like these DIY data sets because it will take more of your time away from the actual modeling process. And that's what this project should really be focused on. That way you can get a feel for how to do this modeling and everything. Okay. And those kind of formats, like when I say what's not a DIY data set, things like if you can get it immediately, like a CSV, a SQLite, a JSON file, or even using an API, right? Those are fine to like do. But if you have to collect this data, like, you have to run it at certain times and stuff like this. Like, for example, you could technically use an API, but then like it only gives you real-time data and you have to like run this over like, a few days to collect enough real-time data. I would avoid that kind of thing. You can possibly combine data sets, like maybe you have some of the data within a CSV and some of this other data is through an API. That's possible to work together too, but just try not to make that like your main focus of trying to get through. If there's some interesting data, but there's not really a way for you not to do DIY, try to think about that maybe for your capstone and see maybe you can start with something that's related here and then try to move into that in your capstone if you're really interested. Okay, sound good? Any questions? Okay, cool. So next few slides will be relatively quick. So kind of mentioning before is like things you should avoid if possible. Natural language processing, computer vision, data that's kind of like review data. So the data is kind of like metadata and stuff like this of like other data sets. It tends to not be very sufficient enough to like do interesting things. DIY data sets, and then anything that requires human input. If you have to take the time to like get this data, and what I mean, like, think of like filling out surveys or like literally copying and pasting many times over, try to avoid that because it's going to slow you down. This is something that I don't have a huge amount of opinion on this, but another instructor had said is that from his experience, he found that like data from education, data from government programs can be kind of wieldly in the sense that there's a little bit harder to get an understanding of like what the data is supposed to represent. I have worked on education data. I have worked on data sets that were from government programs. It sometimes a toss up. I can understand from the educational side, sometimes you have to be knowledgeable in what this is going to be. So just kind of be aware of that kind of stuff. Okay. And then science, there's nothing wrong with science data too. But just be aware that there might be some extra nuances. For example, if you get a particle physics data set, well, hopefully you know a little bit of particle physics before you get started. The main thing is that for this project, I don't want to have too many roadblocks where you're going to have a limited amount of time just to do the machine learning aspect. But if any of these things kind of interest you, definitely, and you're like, Victor, like I really want to do this data set and like it is educational based or something like that, just shoot it by me, and we can look it over and see if it's fine enough to do this. And if it's, honestly, a little more than what's ready for this project, save it for your capstone, and then we can kind of go from there. Okay. All right. Does that make sense to everyone? Any questions about what things to avoid? No? Okay, cool. So last thing, we'll talk actually this on Friday a little bit, but how to manage a little bit of how to do this. Has anyone used Trello or a Kanban board before? So I see hand raised from Hazel. I see a couple nods. Okay, yeah. So this is something that's actually really useful to kind of organize your data set. We'll talk a little bit about this maybe on Friday Feels or something when we officially, put out this project and everything. But just know that you can always like do more, which is kind of like the curse of like doing any project. It's like you can always do more on that project. So just kind of be aware that if there is more to analyze, you can save this up for a capstone or, make this a side project, at the end of the course or during a break or something like that. Cool. All right. And so this comes down to where do you actually get the data? So most machine learning data aggregation sites are pretty good. They're pretty good in the sense that they're decent sized, they're reliable, they usually have a resource like where it came from. And usually someone has already organized the data, so you don't have to like clean it, do a whole lot of cleaning yourself. And that's, again, in reality, will you always have data that you don't have to clean? Probably not. But to make it a little bit easier for this project, it's nice to have this. So some common places are like UCI, so UC Irvine's machine learning data set repository. This is a great set of like, different data sets that are kind of interesting. Note that they tend to be a little bit on the smaller side, so I'd suggest maybe making sure you understand like which data sets kind of fall within like a decent size. It just make it easier. Kaggle data sets I really recommend. I will talk a little bit more on that. There's also this repo about awesome data sets. So basically it's a repo of different data sets that people have collected over time, and that might be an interesting one to kind of spark your interest. I haven't used too much of the New York City Open Data Portal, but I hear that one's really good too. There's also Airbnb data.world. And then there's also one that I added here, Google Data Search or Dataset Search. Has anyone heard about this before? I'm gonna mention too, a couple one-on-ones if possible. So this, I'm gonna show you Kaggle, and then I'll also show you Google Dataset Search. So Google Dataset Search, if you're just like, I'm just curious about like what kind of data set in here, what's really fun, you can just literally type in whatever subject you want, just like Google essentially. And essentially on the left here will be different data sources and stuff like this. And this will actually point you to, for example, different government websites or other aggregation, also Kaggle or Data World and stuff like this. And you can get an idea of like all this information. So it's a nice place to kind of like just search a little bit, see like, is there some interesting data that's out there or related? So sometimes it's kind of fun just to play around with, to be quite honest. I'll sometimes just search for Google Data Search and stuff like this. But yeah, anyway, I think I showed this to someone about, I think it was Andrew, I'm in one-on-one. And so I'm trying to look, for example, you can see here Kaggle come up here, and they're just different sources and stuff. And you can explore it, and it gives you an idea of how big the data set is and everything. Okay, cool. Data sets for Kaggle, I really like recommending because a lot of times you can just search for different data sets in here, but also you can take these data sets and see what other people done. So this is a great way to start off a first project, is just to say, okay, like here's the data, and it gives you a good summary of like the distribution of data, if it's well distributed, if it's, what's it called? Like just the different columns and such like that. So you can see here, this has 100 different columns and things, and you can get a little quick preview. So Kaggle's a really nice way to kind of check out this information. And then also you'll see here in this kernels, there are people who will take this data set and like, maybe do some exploration, maybe do some, what's it called? Like predicting and stuff like this. And so you can check a little bit here too, especially if you're stuck or kind of curious about like what people have done in the past. And check this out. Of course, obviously don't just literally copy them and stuff like that. But I think it might be a good thing to kind of check out. And of course, make sure you like take that time to like think for yourself too and think of like what problems and ways you approach this, especially because you're kind of approaching this as kind of like a playground kind of thing. But don't feel ashamed or like you shouldn't look at any of the kernels for these data sets. A lot of times they can give some really interesting ways to approach this problem and stuff. And there's things like, for example, you can see here is a cat boost classifier, which we haven't talked about and stuff. So you can definitely find some interesting things going through here and such. Okay, cool. Any overall questions about this project, finding data and all that stuff? No? Sound pretty good?
I actually
Yeah. Mm-hmm.
wondering about the deliverable for Jupyter Notebook, because like if we do a grid search that takes over 30 minutes, let's say, we're obviously not gonna enter that while we present it to you.
Right. Mm-hmm.
So it's just us pretty much explaining the results as we go on with the Jupyter Notebook.
Yeah, I think that's perfectly fine. If you want to have something that's more an interactive part of your notebook, like you find that's an interesting thing to do that either you want to try out or you think it does a great job explaining it, you can do things like that. But I think for like training it, you don't have to train it like in our assessment and everything like that. You can think of it, you could literally think of it as like a PDF you print out and like walk it through and stuff like that. That's perfectly reasonable. So don't feel like you have to like make sure it runs in like a couple minutes so that way it's easy to talk about an assessment. If you were a grid search and you find it useful, it takes 30 minutes longer, as long as you're being reasonable in like what you're trying to search for. That's perfectly fine, and that's pretty normal too.
Okay, thanks.
No problem. Yeah, and so we'll also have office hours too. So if you guys have more questions or any specific things too as you guys work through the project, we can talk about that. Okay. Cool. All right, so I'm going to stop the recording here. Oh, is there a question? I think someone.
Yeah,
okay.
one question, real quick. It's just I'm just trying to figure out because I haven't seen before today, and I'm just grasping that it's very vague, like any data set, any problem. So do you have any like further tips for how to come down to one problem or?
Yeah, so I would say if you're really stuck, go check out Kaggle data sets and see what, whatever the most popular are on there and see what people have done in kernels. And that can give you an idea of like, how people approach, kind of doing this problem set. Okay. My overall thing is again, choosing like a data set and say like what kind of problem. Literally just, that's why like going through like Kaggle and stuff like that or UCI's repository is kind of go through and see what looks interesting to you and see what catches your attention. Because usually the reason why I say that's because, again, if you can talk to someone about this, right, like in the future, you want something that's kind of interesting and something that like people will, want to hear you more about. Passion, talking about a project with passion, like really stands out to people versus just doing an interesting project by itself. There's, for example, I think I mentioned this before, one that I really like doing was there's an American Sign Language project I had done. And everyone I talked to, they weren't looking for someone to do a project that was related to that. It wasn't like they're in their like company and stuff like that. But everyone I talked to always got really interested in it. And I could talk in full detail about this project, like what the nuances and stuff like that. And that's because I was interested in it. So if you can find a project like that, and sometimes, you just need to try things out, and this is your first machine learning project too. So don't feel like you have to find the perfect data set that like is going to match well to your soul and like you can explain it so well and like, get really excited about. As is kind of first run. So I think one thing you can do is definitely just see what other people are doing and see kind of how they approach it. And honestly, if you find something like, oh, that's a cool way to do it, try to reproduce that kind of thing. That's perfectly fine too. Yeah. Good question.
Are there any topics that are kind of overdone that we should avoid? Housing crisis?
No, I wouldn't say. I think the housing one might be an interesting thing, but yeah, I would say that, for example, Titanic. There's a Titanic data set. I think I don't know if I've said it already in this place, but if I see Titanic, like people on their resumes and stuff like that, it's kind of like a joke. It's kind of like,
Yeah, you said
like,
that one,
don't do
and
that.
Iris.
Yeah, and the Iris data set. Iris data set's much too small to do like really interesting machine learning by itself. To make it clear is that there's nothing wrong with small data sets. There's actually a full research going through of like, how do you deal with small data sets? But yeah, I would say maybe like the housing data set, I think maybe you guys might be tired of that one by now, since there's been 2 projects that you guys have done already based around housing prices and stuff like that. But I mean, of course, if you're interested in it and you want to approach in that way, I think that would be a cool one to do, especially if it's like something you want to revisit from like your old project or related to your old project. I would say there's not too much off, like on the table that would be like, or sorry, that's off the table that you really like. It's like, oh, don't even do that because everyone's done it. I think whatever kind of catches your interest and stuff would be best. Yeah. Cool. All right, so I'll stop recording here. And of course, as you guys have more questions, you know, sorry, I lost my little thing. If you guys have more questions, you can always ask during our office hours. And of course, Friday Feels will talk a little bit more about the project too. Okay.